Hello, everyone. Welcome to the session. I am Geethu Joseph. I work as an IT asset and project manager at CRESYM. And together with me, I have co-speaker Josep.
Hello, I'm Josep Fanals, CEO of eRoots Analytics.
So in this session, we will talk about OpenSynth expands with D-GITT and RTE7000. So OpenSynth is an open data community launched by Center for Net Zero, CNZ, and it is an LFE project. And its purpose is to open access to AI-generated synthetic data that accelerates the decarbonization of global energy systems. Initially, OpenSynth focused on synthetic demand data, and it has now expanded its scope to become broader open AI energy data, and that including the real-world data from RTE, the French TSO, in partnership with CRESYM. So in this session, we will talk about what is D-GITT and RTE7000 dataset. We'll review the format, content, and non-limitations, and followed by Josep will present datasets and tutorials that are currently being built. And finally, we will talk about the community challenge around the dataset. So what is D-GITT? So D-GITT stands for Detailed Grid Inner Topology Timeseries, a centralized open dataset hub initiated by CRESYM. And the goal is to support collaborative research and power system modeling, making a high-quality grid data openly available. And D-GITT introduces the first contribution RTE7000 dataset provided by RTE. And it also, we would like to, if new potential or additional datasets to be contributed, it's more welcome from other contributors as well. So what is RTE7000 dataset? An open source release of the French transmission network represented in node-breaker topology. It spanned the 3-year period from 2021 to 2023, having snapshots taken every 5 minutes. And it models around 7,000 nodes covering different voltage level across French grid. So what are the expectations of RTE in publishing the dataset? So RTE aims to empower researchers, developers, and AI innovators by providing a detailed and realistic dataset. And RTE invites the global community to explore, analyze, and innovate by creating a collaboration in a cross-disciplinary manner. And this dataset is an invaluable resource for developing AI and optimization models, giving tasks such as grid topology management or power control flow, and training intelligent assistants or digital twin to support power system operation. The dataset comprises more than 300,000 XIADM files compressed in XIADM.bz2 formats. And it is compatible with the PyPossible tool for network simulation and analysis. And each snapshot taken every 5 minutes covers a fine-grained time series of grid topology changes. And it spans a French transmission system from 63 kV to 400 kV. So now, what are the data set it consists of? So each network file includes substations. It provides a detailed a picture of how the equipment is connected inside the substation. It includes disconnectors and switching devices, providing the location and the connection status. The static characteristics of transmission lines and transformers are provided, but the power flow are not included in this network file. The location of load on the network and the connection status are provided, but the injection values are not included in this. And when we talk about generators, the generator energy type, the connection status, the location, and the static type is included. But as I mentioned about the loads, the injection values are not included. Other elements like phase shift transformer, capacitors, and batteries, shunts are also included within this network file. As I mentioned in my previous file, no power flows or injections are included, but it provides a structural and topological information about the network. There are some non-issues identified. For example, the inconsistencies with the IDs, but it is already captured within the GitHub repository as a GitHub issue under OpenSynth Energy D-GITT, which is open to everyone. And it is open for the community so that we would like to look forward for the contribution within the community to solve this inconsistency with the ID. So moving on with the data set, presenting the data set and also about the tutorials. The technical part will be covered by Josep.
Yeah, sure. So these are the data sets that are being provided by RTE. And so we are covering 3 full years. You can scan, for example, this QR code here to get access to them. They are published in Hugging Face. So if you access them, then you would see that there are these many files inside the repository. And so they contain this 5-minute interval grid files. So what we'll do now is to briefly go over this information and see what information we can extract from this. Okay, so let's jump into what we have prepared here. And so I will first explain what this is about. This is the repository on D-GITT. And so we have a bunch of tutorials. The idea is for people to be able to access them and see, again, how can you extract all the information that you would require. So we have an introduction, and then many more. We'll briefly go over the main ones. So it's as simple as opening this Jupyter notebook, and then this is what you get. You see this very big image with all the information that you would see in the network. And so that's quite easy to run. You go in here, you import PyPosible, and then you load one of these grid files. It could be any time step that you would want. So grid model has been properly loaded. And then we have a bunch of methods, functions, to extract the information out of this network. So for example, if we are interested in getting the number of substations, voltage levels, and so on, it's as simple as running this instruction in here. And then you would get to see how many elements we have of each source. If we want to go a bit deeper, you are more of a developer yourself, then you could go into scripting, for example. So here I have basically the same stuff as before. And we could debug it. So let's see what this looks like. You have this grid object. This contains everything. And then here, if we go into function variables, like you don't have to remember anything. You can inspect these and see all the methods that you get by free from PyPosible. So we'll be using a few of them in the tutorial. When it comes to data visualization, it has been mentioned extensively during these talks that it is crucial to be able to spot what's in the network. And PyPosible comes with these features, right? So we go in here, and then, as you can see, we are passing many voltage levels. So we are interested in generating a network diagram around these voltage levels. Again, we run this, and we get something which looks like this, indicating all the connections, the transformers, the different voltage levels that would be in a substation. And I think it's quite illustrative to get this picture. But maybe we are interested in getting a full picture of the whole network and not discerning by each type of voltage level here. So what we'll do is to set a couple of bounds, 420, 380, because we want to get to see the 400 kilovolt buses. And that looks, again, something like this, very detailed. Okay. we'll go into the details because as Geethu has presented this node breaker topology, in comparison to a bus branch, we get all the details here. So we get to see what are the switches, what are the disconnectors, and that's where the richness of this data set comes from. By running this instruction, we produce a single line diagram around this ID, which we'll be covering soon. And yeah, this is what you get. So you see this would represent a substation, and you get to see all the bus bars and all the connections going around. For example, here you would have different circuit breakers. These are these boxes. If they are vertical, they are connecting. If they are horizontal, they are not connecting. And then you also have a bunch of disconnectors. If it's across, it's connecting. If it's a diagonal, it's not connecting. So that's the richness. This is how we'll be able to produce later on a challenge, for example. By having all this information, then you can perform, for example, topological actions on top of that. Once more, you get to see this diagram here. And for example, in this configuration, what we are doing is that we are closing all these top bus bars, so everything would be unified in a bus branch model into a single node here. Okay? Well, we also have some other functionalities to be able to store this information, which I think is not critical now. And you can extract everything. For example, here, around this voltage level ID, what are all the switches that are being related? And you see that there are a couple of columns, or more columns than that, but the relevant ones would be what kind of element this is. It could be a disconnector, it could be a circuit breaker. Is it open? Is it closed? Is it retained, meaning that will this be preserved whenever we perform this branch reduction? So you get to see all this information. What I think is important, and let's jump now into a small issue on the ID inconsistency we're mentioning. So I will switch to the slides 1 second. And this is the kind of information that you would get, for example, for a substation, for a voltage level, for any kind of device. And in main attributes, there is this ID. Now, this ID is supposed to be a unique identifier of this element. It would be like, I don't know, your passport number is not supposed to change across your lifetime. And so, in reality, it does. This is the problem. So we get to have one element, and maybe at different time steps, this ID is changing. So this could lead you to think that this is a different element. But in reality, it could be the same. It's just that there's a slight modification maybe in one character. And so fundamentally, you could think that this is another one. So this is where the inconsistency comes into play. We also have a tutorial for that. And this is just a very simple study that we perform to be able to capture what are these inconsistencies and changes across voltage levels, switches, lines, and so on. So, for example, by analyzing a few time steps, this is the kind of image that you would extract. It's maybe a coincidence, maybe not, but you see that in some given time steps, there are many changes, and in some others, there are no modifications. This is mainly because we are changing the name of this, so there is an addition, there is a deletion, and so more or less this number is coinciding. And so now, if we go into some of the issues that we have collected here, for example, this is what you would get. 2 different snapshots, and then this is slightly changing. So you see this dot 1 in red. Now, the question for you is this the same device, yes or no? You would look at the picture, and you would think that yes, probably yes. And how do you determine this? Well, because if the bus bars that interconnect, that are around this switch, are the same, and they are not mutating, then you could maybe safely assume that this is the same element. It's not that easy whenever you have lines, loads, and so on. This gets much more complicated because what do you take as a reference? What do you take as a source of truth? It's much harder. So I would say that this is an open issue and something that we are trying to come up with a final solution. And finally, to touch a bit on that, the community challenge. So this data set is very powerful, I think, in the right hands and for the right purpose. Geethu has already presented that there are no injections, but this doesn't mean that we cannot perform many analyses based on it. And so to take it a step further, what we want to organize is a challenge that will be fortunately delivered by the end of this year around the concept of remedial action optimization. So you get to have a system operating in a given condition, and then you have the freedom to perform some actions on that. Some actions could be more expensive than others or more complicated. But for example, you could, I don't know, change the tap setting of the transformer, connect or disconnect some shunts, or even redispatch an HVAC link or a generator. And so then it's up to the user to determine what is the most feasible and optimal action that you would like to perform. So that fortunately you have an initial domain here in red, and then you can expand it and move further. So move towards a more optimal operating point. To achieve that, we will come up with different levels of difficulty. I have to say that this is still not something close, so your contributions are welcome. And we're thinking about the following. So first, running on a well-known 30-bus system, only with DC constraints, so we run everything linear, should be quite straightforward. And then we start complicating this. So we move into the full-frame system, the one for the data set we have seen. And we add first DC constraints. We only take a look at a single snapshot. And we progressively complicate it so that we include nonlinear constraints and maybe even moving towards a security constraint OPF, so with n-1. To get into this position, to be able to run the challenge, we need to have injections. That's like mandatory. And the way to do that is to create some synthetic data. There is, for example, this nice reference here from Georgia Tech. So we can do sort of a fitting here by including, yes, it's like solving an OPF at the end of the day, and you get to have injection data that is quite reliable. Of course, not the real data, but something that makes sense for the topology that you have. So you are all invited to participate in this challenge, and we'll update the community accordingly once this comes out. So I think this is everything that we had to present. Now, of course, we'll be more than happy to get some questions, and so we can answer them.
Thanks. From your demo, I understand you have both node breaker and bus branch visualization of the dataset. But in the beginning, it stated the dataset is just node breaker in setup. So where is the conversion done? Is that the Jupyter notebook that did the conversion with possible on the back, in the bag, or the dataset contains both models and just pick the ones you need to load for visualization?
So the data set is in the node breaker, let's say, manner, and then it's on the software to reduce that. So if a switch is closed, for example, you would say, OK, these two buses are fundamentally the same. So there has to be some kind of topological function behind the scenes. This would be, for example, implemented in Possible, BetterGrid, whatever kind of software.
So the switching state is implemented in Possible as a file or as a real-time condition that you import, right?
Sorry?
The switching condition is specified in Possible. Is that a file import, or you subscribe some real-time measurement?
Like that? The switch, maybe we have some. So you see, for example, here we have the state.
Yeah.
Like this would be something that would be changing every 5 minutes. And then internally, whenever you have to run a power flow, the program would be saying, like, OK, if this is open, then, OK, this is open, and this is the impedances that I would get. And then you run the power flow accordingly. So it's on the software.
Thanks.
Okay.
I'll come to you.
Will you update it for upcoming years? Just keep adding years as time passes?
Sorry, I think the audio is maybe not that good, but...
Yeah. Will you also update it for next years when...
Okay.
time passes?
Well, that's not on me. I think that depends on RTE. But personally, yes, they are quite open when it comes to that. So we also look forward to it.
And you said 5-minute values for the time series. Is that just averages or also min-max within those 5 minutes?
We have to see. We still have to produce the injections.
Yeah.
So I cannot say for sure.
Yeah. And yeah, I guess that's okay.
Thank you for your presentation. Now, I must admit that I came in like a couple minutes late, so if you address this, just let me know. But in the Netherlands, a lot of utilities have tried to publish this kind of data and got a lot of pushback from security services and that kind of stuff because of the risk of this kind of information coming out, perceived risk too. So can you elaborate, can you tell us anything about how you convinced the people the people around you, the other stakeholders, that this was an okay thing to do? And do you have any advice for other utilities that are trying to publish this data as well?
So I'm here on behalf of eRoots Analytics. We are the company maybe behind the scenes running the tech, let's say, but not so much on the political side. This is more on CRESYM. So Geethu, if you can answer that.
I didn't hear. Oh, okay.
Actually, for RTE opened this data set because there was a big request from the researcher point of view or AI innovators that let's open this data sets for anyone to play with it. And also, it's we have this data set is compatible with PyPossible tool, which is also an open source. So we are bringing an information to everyone that why not open the data sets where if you see this data set, you can see that their injections and path flows are not there, but it's okay to include the injections as a synthetic data. So this is an information that we would like to provide it. And D-GITT from CRESYM, this is what is an initiative that we have taken, that the RTE7000 dataset is the first potential dataset within D-GITT. So it will act as a central dataset hub, and other potential datasets can be included within this. So any participants, any researchers, or any innovators would like to plug and play around, then it's open to everyone. So that's the goal of this.
Yeah, one more question. This one's more technical. You mentioned that there's some duplicate IDs. Is there, can people report those, and will you fix them, or is there a process for that?
Yeah, for sure. This is what we are doing, actually. So see, this is one of the advantages, right, of having an open data set. And if we go here into the issues, we have, for example, our colleague Carlos reporting some of this. And so what we would like to see is this open dialogue between different stakeholders taking a look at this.
So all the ID inconsistencies are already captured. Whatever we have identified are already captured in GitHub issues, and we welcome the community to contribute to that.
Yeah, also about these inconsistency in IDs. Have you guys talked to the people at RTE to see if there's any systematic any patterns behind those inconsistencies that may repeat themselves versus just a one-off case? Because there seem to be quite a lot. So there's a suspicion there that there might be something hidden that's systematic.
Yeah, for sure. So we are in conversations with them. They are aware of the issue. This is an issue, well, that's not new. It's an issue that has been going on for several years, and they are quite aware of it. Unfortunately, it seems that they couldn't come up with a solution or a quick fix. So this is something that, again, was mostly investigated by Carlos. How can we take some source of truth and from this determine what are the inconsistencies going on? We still don't know the source of that issue. So, more effort to be put into this.
Thank you so much, and please do connect with us if you have any questions later.